Why, hello students. I'm going to be telling you today about what you're going to do with your fan cart lab. So one of the first things you want to make sure to do is that you got your track, that your track is level. If not, you can adjust it right here. And that you have your bumpers firmly attached at either end so that the fan cart does not go over the table. Next up, you're going to get your Go Direct sensor cart, turn it on, and you've done this already, but I'll show you again how to connect. So again, you go to Vernier Graphical Analysis, and so hopefully you can see that over here. All right, it loaded up. And then go to Sensor Data Collection. Once you go to Sensor Data Collection, you should see the cart's ID number show up. So my cart says 297 at the end under the barcode, and here it says 297, so I'm going to hit Connect. If not, another thing you could do is connect it directly through a USB, because, yeah. Now, again, these carts can detect position, velocity, and acceleration, but also force. And all we're going to use these for today are force. So I'm going to select, if you see, once it's connected, it says Connected Devices. I'm going to go to Sensor Channels. So I'm going to go to Sensor Channels. I'm going to uncheck Position, and then I'm going to check Force. So now that I've done that, I'm going to hit Done. And I should see a force versus time graph. Now I got to calibrate. So first off, I want to zero out. So I'm going to make sure this is screwed in firmly, not tightly, but firmly. So don't go crazy on it. And then I'm going to make sure this is 0. It pretty much is 0. So, but I'll just show you. If it's not 0, you can zero it out by clicking the bottom here and then clicking 0. So I'll do that here as I'll select 0. But the next thing I'm going to do now is calibrate. So I click the same bottom here where it says force, and I'm going to select calibrate. So I'm going to hang a 1 kilogram mass from the hook. And the thing is that I actually know this force. So I'm going to input that force right now. But notice I'm not moving. You shouldn't be moving up or down. You should stay as still as you possibly can. It turns out the force acting on this 1 kilogram mass is 9.81 newtons. So you just put in 9.81, then select Keep. Next up, it wants a second known value. So the second known value, use 500 grams. Put that one on there. Again, don't move. Then you're going to write 4.9, and then again, hit Keep. Then select Apply. Once you've done that, this is ready to go. So you're going to put it on the very end right here and just let it stay. So I see it moving a little bit, so I'm going to adjust these down. So there we go. And then I'll put my fan cart next to it. There we go. Okay, so and then I put my fan cart next to it like that. And now I am ready to, so I see also though right now that it says negative 12 newtons. So you want to select again force. I would make it 0 out. And I think you also want to do reverse. Click on reverse as well. I think that's going to give me positive values then. So what you're going to do now is each fan speed is associated with a certain force, right? So each fan speed is associated with a certain force. So 3 is going to be stronger force than 2, which is going to be a stronger force than 1, et cetera, et cetera. But it's going to be a constant force once you get that. There's an angle thing right here, and there's a little nub at the end of these fan carts here. You want to make sure that 0 is aligned with that nub, that the fan is going horizontal. So I'm going to now get my forces. Once I have the forces, I know what force is associated with what fan speed. So I'll start with the biggest one, 3. So I'm going to hit 3, and now this fan cart is pushing up against this force sensor. So I know, and then I'm measuring the force. I can read it right here. It's about 23 or 25 newtons, but I'm going to collect a lot of data points and get the average of that. So I'm going to hit collect, and I see the graph being plotted here. Once it does that, I'm just going to select a section, and I'm going to go to View Statistics, and I'm going to look for the mean. I'm going to find the average. So this one is 0.231 newtons. So I know at fan cart speed 3, it's at 0.231 newtons. Now I'm going to go to fan speed 2. So I'll just show that really quickly. So I'll go to fan speed 2. Again, I'm going to collect. Let it go. Once it's done, highlight it, view statistics. I get that average. This average is 0.24 newtons. And then I would go to fan speed 1. Next up, you want to get more, right? That's just 3 fan speeds. You want to get even more fan speeds. So I would do, to do this, you can go to fan speed 3 and change your angle to 15 degrees. Then you can change it to 30 degrees. Then you can change it to 45 degrees and try and get other fan speeds so that you can vary the force. So you got a lot of different ones there. So I'll do just so I changed my angle like I did, and then I'm going to go and put again fan speed 3 and measure this. All right, and it went. So I'm going to highlight now, view statistics, and this one's at 0.218 newtons. So now I know that at fan speed 3, at 15 degrees, the force associated with it is 0.218 newtons. And then to get my acceleration, right, you're going to use that calculation that you did with the distance and the time. I'm going to find out what my distance is. And I'm going to go that distance, and I'm going to measure the time it took to go that distance and get my acceleration that way, right? So that was fan speed 3 at 15 degrees, and so I know with that force, that's the acceleration that it's associated with. You want 2 trials for every force that you use. And I would say you want at least 7 or 8 different forces. So 2 trials for 7 or 8 forces, that should give you like 16 data points. That's pretty good. All right. So that's how, so that's how we're going to find how force and the relationship between force and acceleration. What about the relationship between force and mass? So again, we want to hold the force constant this time. Between mass and acceleration. What's the relationship between mass and acceleration? So with that one, we want to hold the force constant because that's not varying here. Then to vary the mass, right? So again, we're going to hold the force constant, but then we can put different masses on top and see how that changes the acceleration. Again, you want to go from very large masses to no mass at all. And then whatever variation in between. So, and make sure the increments are equal. So for example, if I go from 0 to 100, let's just say 0 grams to 100. Sorry. Well, hopefully that helped.